Hello and welcome. In this lesson, we'll learn how to add and subtract geometric vectors and discuss some of the properties in addition and subtraction. So let's get started. Recall that subtraction is a form of addition. For example, the subtraction 9 minus 6 can be interpreted as the addition of 9 with negative 6. A similar concept applies to adding and subtracting vectors, and this is the reason why you will find the methods of adding and subtracting vectors very similar. There are two different ways of adding or subtracting vectors. One is what we call the triangle law of addition, and the other is what we call the parallelogram law of addition and subtraction, obviously. So we're going to get started with this example where we're given two vectors u and v. And we're going to try to add them and find the sum u plus v, which means we start with vector u and add v to it. And we're going to try to add them as v plus u, which means that we'll start with vector v and add u to it. We're going to check and see, would the answer be the same? So if you want to add two vectors by using the triangle law of addition, we have to follow two steps. Step one, we have to draw the vectors head to tail. So if I'm adding vector u to vector v, it means that I'm going to start with vector u, which means that vector u won't change position. It will stay exactly where it is. And then I'm going to draw vector v, which is added to vector u, by placing the tail of the second vector, the vector I'm adding, to the head of the first. So, in other words, vector v should be moved over with the tail at the head of vector u. The resultant vector will be the one that connects the tail of vector u, the first vector that in the addition, with the head of vector v, which is the vector added. So this would be the resultant vector, which we call vector u plus v. So in a similar way, we are going to draw the sum, or to find the sum of vectors v plus u. So what that means is that we'll start with vector v, and then we'll add vector u to it. So let me bring vector v on the other side of the space in here, just so that we can use the space more efficiently. So I'm going to bring vector v somewhere here. This is vector v. Now, this is the starting vector. Now, I'm going to add vector u to it. So what that means is that vector u, I'm only drawing this for the purpose, again, of drawing the exact same vector there. So I'm going to take vector u. That's the vector that is added to vector v. I need to do one little thing here. And I will place the tail of vector u to the head of vector v, because that's a vector that is added to v. And now the resultant vector will be the one that connects the tail of vector v, the starting vector, with the head of vector u, that vector that is added to the first. So here we go. This would be the resultant vector v plus u this time. And now I want us to compare vectors u and v plus u. So u plus v and v plus u. Are they the exact same vectors? So for this, for the purpose of comparing them, I'm going to drag this vector here, u plus v, to v plus u, and as you can see, they coincide, so they're exact same size and same direction. So in this case, we're going to say that the order in which we add vectors, so u plus v or v plus u, does not matter. In this case, we're going to say that vectors or vector addition enjoys the commutative law. So in other words, this is what we call the commutative law of addition. Now, in a similar way, now we're going to learn or practice how to subtract two vectors. There is only one little extra step that we need to follow here. So if we are finding the difference u minus v, we want to do this as the sum u plus negative v. So therefore, we're going to start off by drawing the vector negative v first. So if this is vector v, vector negative v will be the exact same but pointing in the opposite direction. So let me draw this here. This would be vector negative v. Now, because we're adding vector negative v to vector u, we are going to place the tail of vector negative v onto the head of vector u. So here is the head of vector u, and here is the vector negative v. So the sum of vectors u with negative v will be, again, the sum, the vector that connects the tail of vector u, the first vector, with the head of the vector negative v, so the vector that we're adding. This didn't turn out very nicely. It's not working. Okay, so I'm gonna try to make the line not as straight, maybe. So, okay, here we go. I think this is better. What an interesting vector. So this would be vector u minus v. Now, in the soft copy of your handout, you have some activities that you can also complete. So in vector addition, again, these are from GeoGebra. So what we have in here is the sum of vectors u plus v and v plus u. So we're going to try to add vectors u plus v, which means that we're adding v to u. So when we add v to u, let's finish the addition. This would be the sum of the two vectors, u plus v. Now, if we want to find the sum v plus u, so we're adding u to v, it means that we're adding vector u, or we're placing the tail of u onto the head of v. So this is how you place them. And if you continue this, you can see the sum u plus v. And as you can see, both vectors, I'm going to show both of them. V plus u and u plus v are exactly the same. In a similar way, we can look into the vector subtraction. Okay, so we're adding vectors u and negative v. So let's slide this over. You can see that vector v is being vector v is being placed first there, and then we're drawing vector negative v, and this would be the sum u plus negative v. Now, we're going to try to do the same thing with u plus negative v. So this time, we have vector v, we start off with v, we add u, draw negative u, and this would be u minus v. So if you look at both vectors, u plus negative v or v plus negative u, you can tell that the two vectors are the same. So they're equal to each other. So this is a triangle method of addition or subtraction. Now let's take a look at the parallelogram method, which produces the exact same answer, obviously, but the method of adding or subtracting is slightly different. So we use different steps. So we have two vectors here, vectors u and v, that we're trying to add. And I'm going to follow the parallelogram law, which means that we have to draw the two vectors tail to tail this time. Remember, in triangle law, we placed the vectors head to tail. And this time, we are connecting the vectors tail to tail. So vector v, the tail of vector v will come to the tail of vector u. And from here on, we're going to draw a parallelogram by using these two sides, these two vectors as the two sides of the parallelogram. And that's where the name parallelogram law of addition comes from. So I will draw one side or one line parallel to vector v. And here goes another line here parallel to vector u. Now we have created a parallelogram, so I'm going to delete the rest of the line that I don't need. So as you can see here, we have a perfect parallelogram. So where is the resultant? So the resultant will always be the diagonal that comes from where both tails are, and it's heading towards the opposite vertex. So this would be the resultant, u plus v, or v plus u. We already know that the order in addition won't matter, or subtraction for that matter. Now, we're thinking, how do I know that this method works? I understood the triangle law, but do both methods give the same answer? So let's give it a try by using the triangle law of addition. So I'm going to start off with drawing the vector u. And I'm going to grab this one here. And at the tail of vector u, at the head of vector u, I will place the tail of vector v. And now I will connect the tail of u with the head of v. And I want us to compare the sums u plus v found using two different methods. So as you can see, the two methods both produce the same vector. So if we want to prove, so why don't we grab this vector, bring it here to see if they are exactly the same, and they are. Okay, so how about the parallelogram law of subtraction? So how does that work? So just like we work with triangle law of subtraction, we're going to start off by drawing vector negative v this time. So we'll write the difference u minus v as u plus negative v. So here is vector v, which makes vector negative v go this way. So we'll grab that. And we will bring the tail of vector v, forgot to grab the head as well, at the tail of vector u. Here goes v, and here goes vector u. And the sum of the two vectors will be the diagonal. So we have to draw the parallelogram. And another one which goes right here. And here goes our beautiful parallelogram. And the sum of u plus negative v would be the diagonal that comes from the tail of both vectors towards the opposite vertex here. So this would be the vector u minus v. Again, if we follow the triangle law of addition, it means that we're going to have vector u. Let me just place that. Oopsie. Here goes vector u. I'm going to bring it here so we have enough room. And here is vector negative v. Head to tail, right? So that's negative v. And the sum u plus negative v, or should we say the difference u minus v, will be this green vector here, which seems to be the same as the one that we got by using the parallelogram rule.